The first topic in this video is the importance of data. Actually, data is the most important asset of the 21st century. Companies like Google, Facebook, and Instagram profit from data. They are, you might say, in the data business. These are currently among the most valuable companies of all time. Data can allow you to understand and solve problems, review performance, improve processes, and make better decisions as long as you can derive insights from it. The step between data and insight is where the value lies. Of course, data plays a role in network automation. You can automate actions based on insights, or you can gather network data and try to predict consequences. Data can be the difference between a migration being a success or a failure, as it can enable you to quickly identify a drift between the deployed configuration and the expected configuration. Data can also help you anticipate and identify a defect on power supplies that disrupts the network by continuously comparing measurements. And data from multiple logs can help you determine what has been crashing a switch. Alright, now let me to explain about data formats and models. Actually, data can come in many formats. It's important to know at least the common ones in order to be able to correctly interpret them. Without this understanding, misinterpretation is possible. Take, for example, the word moron, M-O-R-O-N. In English, it does not have a very nice meaning, but in Welsh, it means carrot. This is an oversimplified example, but it illustrates the type of misinterpretation that can occur with network data. Data formats play an important role when interacting with systems. Some components such as APIs or tools such as Ansible, as you will see later in this series of videos, work with specific data formats. You need to know how to compose data in such formats to be able to take advantage of these components and tools. Data models play an important role but are often confused with data format. A data model defines what values and types data can exist on, as well as how each entity relates to each other entity. In short, the data model defines the data architecture. It abstracts the underlying configuration and exposes it in a common format. To better understand the difference between a data format and a data model, say that you are filling a form on a website. A data format would be the representation of words in letters based on UTF-8 or ASCII. For example, whereas a data model would restrict the type of words you can insert in each field of the form, for example, requiring @ and .com in the email field. Data models are very important, as you will see in this video and also in future videos, because systems want to enforce a specific data structure and range of values, not simply data in a specific format. For example, a router wants the OSPF process ID to be an integer ranging from 1 to 65,535, not any integer. Actually, this video and the future videos discusses the most common data formats and models that you will interact with in a networking environment like YAML, XML, JSON, syslog, NetFlow, IPFix, and Yang. For the start of talking about the data formats and data model, let me explain a little about the YAML, yet another markup language, and after that in future videos we will learn about other data formats and data models. YAML, which initially stood for yet another markup language and now stands for YAML ain't markup language, is a language designed with humans in mind. Its format is human-friendly and it is used with tools such as Ansible. YAML has a number of quirks, include the following. A YAML file should start with 3-, as you can see here, although this is not mandatory. And then YAML is case sensitive. And then a YAML file has the extension .yaml or .yml, .yaml or .yml. And finally, indentation, is important in YAML, unlike in other data formats, such as XML. In a file, the number of spaces used for indentation must always be the same. For example, if you start by using 2 spaces, you must use 2 spaces in the rest of the file. By convention, 2 spaces are typically used and tabs are not permitted. This example shows an example of a YAML file with correct indentation and as an example of a YAML file with an invalid indentation. Let me to explain it. In this example, the valid file, this file, has multiple elements and each child element has 2 spaces more than its parent. As you can see here we have 2 spaces more than the parent. For example, the element CSR1000V, this element, starts 2 spaces after from its parent devices. In the invalid file, you can see that the element address has 4, as you can see, spaces more than its parent Nexus 9000. Although the element OS under the same parent has only 2 spaces. This is valid and this is invalid. In YAML, there are 3 data types. First, a scalar, second, list, and third, dictionary. What is the scalar? A simple value for a single key. What is the list? A collection of values for a single key. What is the dictionary? A collection of key value pairs for a single key. YAML also supports nested data types. It's important to represent data in the way that best suits your purpose. Doing so makes it easier to access the data when it is stored. Here we have a scalar type of data in this example. A scalar, it has only one, actually a simple value. And after that, here we can see a list. This is a collection of values for a single key. And finally, here we have a dictionary. This is a collection of key value pair, address, then the value. This is key, this is value. Again, key, value. Actually, this is a collection of key value pairs. But and also here we have N7K, again, key, value, key, value. In a scalar, we have only one value. In list, we have multiple values. And in the dictionary, we have the collection of key and value pairs. YAML also supports flu style data. All of the previous examples are in block style. Look at here, this is a block style YAML and this is the flu style YAML. Even though YAML supports flu style data, you should use block style whenever possible, as it makes reading the code much easier. In the bottom example, in the flu style YAML, you can see that in flu style, lists are represented using a square bracket notation and dictionaries are represented using curly brackets or curly braces. The scalar data type is represented the same way as in a block style. Look at here. Here we have a scalar actually, and here again we have exactly same value. But about the list, this is the list, and here we have the same list, but here you can see that we have some indentation, but here we don't have it. Actually, here we have only the square bracket, and here we don't have a square bracket. And in dictionary, you can see this is a collection of key value pairs, and here we have this representation that we are using curly braces, And after that, for example, for CSR1000V colon, we have this key value pairs, key address value 100001, and then the next key, and here we have a comma, and then the next key and the next value. Okay, and after that, here again the next components N7K, and this is the key value pairs of N7K. This is the flow style data or YAML, and as I mentioned before, it's recommended to use block style. It is more easier to read and work. Sometimes you might want to add extra information to a YAML file, for example, to explain complex functions or to explain your reasoning when you share files with a broader team. You can achieve this by using the number sign or hash, as you can see here, symbol, which starts a comment in a YAML. This device might change IP address. Okay, when a YAML file is parsed, comments are ignored. The following example uses a comment to include that a specific device might change IP address in the future. As you can see, this device might change IP address. Also, say that you would like to enforce a specific structure for data. For example, you might want each entry to be a pair, device name and IP address. As you can see here, look at here, device name, IP address, key value, and then key value. Okay, in the bottom YAML snippet, you would likely run into trouble because device 01 and device 02 have different data types that you expect. Look at here, device 01 and then device 02. They have different data types. This is true or false, and this is a scalar value, as you can see. Actually, instead of being a string, scalars here, device 01 is a list, and device 02 is a scalar with a Boolean value. Okay, from a data format perspective, this is a well formatted file, but the data types are problematic. The data enforcement in this example is typically called a data model or sometimes a schema. To achieve this type of enforcement in YAML, you would have to use a tool, as there are no native methods available. There are, however, plenty of tools available. For example, the following code would be the schema for the previous example using the YAML tool. Here you can see device 01 colon string, and then device 02 next string type, and device 03 next string type. This YAML schema enforces value types so that each device key must be a string. If you use this schema with the previous example where devices have values of type Boolean and list, even though that example is a well-formatted YAML, the data would not be accepted. Using data models is critical for data validation and security. You will see in the following videos that different data formats have different ways of ensuring that receiving data has the expected structure.